All right, very good. So some of you guys did get started on the discussion. So blood pH should be at 7.4, and the range is very small. We can only range from 7.35 to 7.45. So if we're outside this pH range, we go into a coma. We die. Our body shuts down. We're out of homeostasis. So we need to understand the pH scale. So what is the pH scale measuring? Huh? What's the pH scale measuring? It's in the name. The pH scale is measuring these guys, H pluses. The pOH scale is measuring what? These guys. So our pH scale ranges from 0 to 14. So right dab in the middle is neutral, 7. Which side is acid? 0 or 14? High pH or low pH? So an acid for us is anything that releases H+. A base for us is anything that releases OH-. Right? What happens when you take H+ and you let it mix with some OH-? What happens there? What do you get? How many H's do you get? How many H's do you have? Here's one H, here's another. How many O's do you have? Huh. H, how many H's? How many O's? What's the charge? Neutral, right? You got a positive and a negative. You add those together, it becomes neutral, right? So, what is our pH scale based on? Bruce Lee's favorite drink. Right? All right. So, this means acid, a lot of H+, and that's what we're measuring based on the log 10 scale. So, you're going to have to use your log or your 10 to the x exponent. And then this side is base, high pH, and you get a lot of OH-. So what the pH number is the negative exponent of the log base 10. Right? So I'm going to have to teach you guys how to punch that in. But before we do, pH plus pOH will always equal to 14. So if you know your pH, you know your pOH, right? So let's plug and chug A. So it says take your pH, which is 7.8, add it to your pOH, and it should equal 14. So what is our pOH? How do you get that? You just subtract. Just take 14, subtract 7.8. That's it. Easy enough. So let's do B. What's our pH in B? 0.3. So the pOH would be 13.7. Yeah. Super easy. So you got to know the relationship between pH and pOH. You know one number, you know the other. All right, I got the pOH this time. Find the pH. So for C, we're looking for pH, but I know what pOH is. It's 2.4. And that still equals to 14. So what's our pH this time? Yeah, just take 14 minus 2.4. 11.6? Yeah. All right, let's find the last pH. So we got pH plus 13.7 equals 14. So our pH this time is 0.3, right? Just like this one. Not too bad. You guys understand the relationship between pH and pOH. All right, let's talk about base 10. All right, what is 10 to the 0? What's 10 to the 0? We did this week 1. It's 1. Oh my God. All right. So your exponent is 0. Your pH, if it's 10 to the 0, that means you have 1, which is equal to 100% H plus. So if you're at pH 0, we're looking at that exponent, right? 10 to the negative 1. What does that equal? 0.1, 1/10. Right? So the negative exponent, if I have this much, which is 10%, right? 0.1 decimal is 10%, everyone agrees? Then that is plus. That is a pH of 1. So I'm right about here, pH of 1. If I am 10 to the negative 2, what's the decimal? So that is 1% H plus. Right? So I am at a pH of 2. Right? So this is how the pH scale works. It's a logarithmic scale. Are you guys familiar with the Richter scale? Who is Richter? What does he measure? Earthquake. All right, so if you have a magnitude 5 earthquake versus a magnitude 6 earthquake, how much stronger is the 6? Twice as strong? 10 times as strong. Between a magnitude 6 and a magnitude 7 earthquake, how much stronger is the 7 from the 6? 10 times stronger. So how much stronger is a 5 and a 7? How much stronger is the 7? What's 10 times 10? 100 times stronger, right? So the Northridge earthquake, what was that? It was like a 6. And what was Fukushima? 8. Who was here for Northridge or Loma Prieta in the Bay Area? All right, it shook for like a minute. The Fukushima one, the Japan one, was how much times stronger? 100 times stronger, right? So 10 times or 100 times more devastating. So pH 0 between pH 1, 10 times more hydrogen. pH 1, pH 2, pH 1 has 10 times more. If I had a pH 3, pH 2 would have 10 times more H plus. So it is an exponential scale. So the pH is the negative exponent. So if I have 10 to the negative 1 concentration, that's a pH of 1. If I have 10 to the negative 2 concentration, then I have a pH of 2. If I have a negative that much, then it's a pH of 3. Right? And this, of course, is the molar concentration. Right? So if you see molar, that's moles per liter. We figured that out yesterday. And if you see any numbers in brackets, that also means molarity as well. All right, now that you guys understand the pH scale. All right, so now you guys know how to enter that in. So in your calculator, just punch in the number 1, 2, 3, 4, 5. All right, and once you push enter, it's going to give you the answer as -6. Right? But we want to take the negative of it, so the pH for A would be 6. So let's do B. So same thing, molar concentration. So log of 0.00823. That should give you a negative number, and then you just take the opposite of it. So what do you get for log of 0.00823? 2.08. So your pH would be 2.08. So molar, or in brackets like this, it means molar concentration. Capital M or brackets. So for C, all you gotta do is take the negative log of 0.00523. And then you just take the positive of it, which is 2.28. So yeah, for us, we're not going to be dealing with negative pHs or negative POHs. Right? All right, what if you're given hydroxide concentration. Right? In this case, we're given hydroxide concentration. So what you're going to do is you're going to find the pOH, and remember the relationship, pH plus pOH equals 14. So once you find the pH, you know the pOH. In this case, we're going to find the pOH to solve for pH. Okay. All right, so let's do D over here. So D is log of, the negative log of 0.0001. What do you guys get? -4. Take the negative of it, so it would be 4. So your pOH is 4, right? But we're not looking for pOH. We're looking for pH. So pH plus 4 must equal 14. So what is our pH? 10. Yeah. So indirectly, we're able to solve for pH. If you know your pOH, you know your pH. All right, let's do E. Same way. Negative log of the concentration, 0.0526. What do you guys get? -1.27. Okay, so your pOH is 1.27. What is your pH? So pH plus 1.27 must equal 14. All right, everybody, try the last one. Find pOH first in order to find pH. What'd you get? pH or pOH? pH is 7.48. Yep, so your pOH is 6.52. Yep. So that is the relationship between pH and pOH and how we solve for it. So if you know the concentration, you can find the pH. Vapor pressure. So we have water, H2O liquid, right? And we have H2O gas. And we have H2O aqueous, right? So different states of matter. Here we're talking about water vapor or gaseous water in the atmosphere that you're breathing in. So is this involved in oxygen exchange? No, water vapor is not. So it's going to take up space, right? You guys recall relative humidity and humidity? Right? So the amount of water vapor in the air is based on the temperature. The hotter it is, the more water you can actually hold in the air. Right? So it's kind of counterintuitive. So open up your book to page 196, and you'll need to use these values for the homework as well. So at 28 degrees Celsius, what is the partial vapor pressure? The pressure of water at 28 degrees Celsius. So you take your gauge pressure reading, which is 720. B is for barometric. So this is what you're measuring your atmosphere as. At 28, there was how much vapor pressure? 20.3? 28.3. So all you do is subtract the water pressure from the barometric pressure, and then you'll get your actual gas that's involved in exchange. So how much pressure, gas pressure, is actually going to be involved in exchange? So when we do the combined gas laws, we'll now have to correct the partial pressures first. So that means change everything into torrs or millimeters of mercury, because the values of water pressure are given to you in millimeters of mercury. So you gotta be careful. All right, at 36, what is the partial pressure of water? 44.6 millimeters. So we just take the difference. 920 is what the gauge is reading, the barometer is reading. 44.6 of that pressure is due to water, that's not exchanging. So how much is actually exchanging? So we'll use that number, this pressure number, in our gas equations. 1.1 atmosphere, right? So easily converting atmospheres into torrs, you take the 1.1 ATM and you multiply by 760, right? Because there's 760 torrs, 760 millimeters. And then at 20 degrees, what is the vapor pressure of water? 20. 17.5. All right, so just convert atmosphere into torrs first, conversion factor 760, and then subtract 17.5. What did you guys get for C? 60 who? 18.5. There you go, that's better. So it's 1.1 times 760. Push equal first, because it's in parentheses. Please excuse my dear Aunt Sally, and then subtract. Yeah, don't forget your orders of operation. D, we got pounds per square inch. The conversion factor is 14.7. Oh, you got to divide. 14.7. And then we're in atmospheres, right? So let me start over. So 15 psi over 14.7. That'll give you atmospheres, but we need to change that into torrs. So it's a two-step to get into millimeters of mercury for D. So just change your pounds per square inch into ATMs, divide by 14.7, and then multiply by 760. So now we are in torrs. We just need to subtract the partial pressure at 16. What's the partial pressure at 16? 13.6. So convert into torrs and then subtract the partial pressure. What did you guys get? 7? 7, 6, okay, not too bad. So that is correcting. Now we are going to use it. Yeah.
Just, I don't know, but the top ones we're putting like 691.7. The last one we put in 0.91. Should we do that, or do you just want the whole number?
Yeah, for this one, don't worry about it. It's only on the exams. There'll be specific directions on the way around. All right, so here we're just learning how to plug and chug. So if you left a couple decimals, don't worry about it for this one. All right. So here I rearranged the equation for you, but you can always just use PV over T equals PV over T. So the easiest thing to do is do our corrections first and then plug and chug. So for pressure 1, it's 750, but we need to subtract the partial vapor pressure at water vapor pressure at 25. So how much pressure is at 25 degrees Celsius? 23 point what? 23 point. All right, so let's subtract that. 750 minus 23.8. You got 726.2. All right, so we'll use this number. mLs is okay because both of our volumes are in mLs. We don't have to touch it. But we know that temperatures need to be in Kelvin, so let's add 273 here. $298, right? Yeah, 298. And then for P2, we have to subtract the partial pressure at 37 degrees. What is the partial vapor pressure at 37?
47.0.
47. So this would be 713. Yeah, 713. And then lastly, last temperature, 273. I think this is 310. Yeah, 310. All right, now that we got our units where we want them, we can plug and chug. So P1 is going to be 726.8. We're going to multiply by V1, which is 100, and T2, which is 310. And then divide all that by T1, 298, times P2, which is adjusted to 713. So 726.8 times 100 times 310 divided by 298 divided by 713. Remember, you got to do everything down here in the parentheses first. Temperature went up, pressure went up, the volume also should went up. What is it now? 106. Yep. So temperature went up more significantly than pressure. So yeah, volume should go up. Yeah, you guys got 106. Able to punch it in? All right, last one for the module. Let's do some corrections. All right, so at 20 degrees, what was the vapor pressure again? 17.5. So our corrected pressure 1 will be 712.5. Yeah, about right. Volumes are in ml, so we don't have to touch those. Celsius, of course, at 273. 293. And then for P2, we got to subtract the vapor pressure at 36. What is the vapor pressure at 36 Celsius? 34.6. 44.6. Okay. So minus 45, so 711.4. 36, that would be 9, 0, 309? Yeah, about right. All right, let's plug it in. P1, 712.5. V1 is 125. T2 is 308. No, 309. Sorry. T1, 293. And P2 is adjusted to 711.4. So let's see, the temperature went up again. Pressure didn't change too much, so I'm expecting the volume to go up as well. What'd you guys get? 126, 127? Yeah, so it went up a little bit.
How are you punching out all these?
Okay, how am I punching it in?
Yeah, you multiplying all of this.
7.25 times 125 times 308, 309 divided by 293 divided by 711.4. No, I do not. Remember, multiplication and division is communicable, so you can.
Yeah, that's what confused me.
Okay, this is the division sign. Okay, the division sign. So you must do this. Okay, together first. You got to do this first, or you can use the communicable distributive properties of math, right? Because this is under the division sign, right? So you need to divide by 293, and you also need to divide by 711, right? So you guys are not following. Yeah, so go back. If you don't know the shortcut, simplify the top number first, write it down. Simplify the bottom number, write it down, and then divide. So if you're not sure where this comes from, go back to the algebra one. So try punching it in, because somebody texted me yesterday, they watched the video 40, 50 million times, and they finally got it. So it was your orders of operations. So yes, there is a multiplication here, but guess what? You needed to divide first by this big old quotient, this big old division sign. So divide by 293, divide by 711. Got it? You guys got it now? Punched it in? Everything on top divided by everything on the bottom. All right, so that is it. No new taxes. Wait, that was Bush. And then he gave you guys some taxes. So don't trust him. No new types of problems. All we're going to do is build on what we learned. So you guys got everything in memory. All right, and then you guys got all the equations to apply it. And now it's going to be brand spanking new stuff. But you'll have everything. You have all the foundation to solve it for the final.